I'm looking at how different settings in the gradient boosting regressor model affect how well it avoids overfitting. Overfitting happens when the model learns the training data too well, including its noise, and performs poorly on new data. I need to find the hyperparameter adjustments that make the model more generalizable and less sensitive to noise. Let's understand overfitting in the context of gradient boosting regressors. It's a machine learning model that builds an ensemble of decision trees to make predictions. When it overfits, it becomes too specialized to the training data, and doesn't generalize well to new, unseen data. Think of it like a student who memorizes the answers to a test instead of understanding the underlying concepts. Increasing min_samples_split means I'm requiring more data points before I split a node in a tree. This prevents the model from focusing on tiny details and noise in the data, which is what causes overfitting. I'm making the model more resilient to noise by requiring more substantial evidence to make a split. Increasing max_depth lets the trees grow taller, making them more complex. This is bad news for overfitting. Taller trees can capture very intricate patterns, but they can also pick up noise in the training data. This model will likely perform worse on new data. The learning_rate controls how much each tree influences the final prediction. By decreasing it, I'm making the model learn more gradually. Each tree makes smaller adjustments, which leads to a more stable and less overfit model. Think of it as taking smaller steps on a mountain trail instead of taking giant leaps. It's a smoother climb to the top. Prediction. Increasing the number of trees, n_estimators can improve performance, but only if the model isn't already overfitting. Without controlling the learning_rate, adding more trees can worsen overfitting. Because adding more trees without changing the rate at which each tree learns increases the complexity. It's like adding more detail to a portrait that already has too much detail. The result is a noisy and messy picture. This question asks you to identify which settings in a gradient boosting regressor model will help reduce overfitting. Overfitting happens when your model learns the training data too well, including the noise, and performs poorly on new, unseen data. We need to find the settings that will improve the model's performance on new data. This is the core problem. I'm looking for solutions to stop the gradient boosting regressor model from overfitting. That means I'm looking for ways to make it better at predicting house prices on data it hasn't seen before. Increasing min_samples_split means I'll need more data points to split a decision node in the tree. This prevents the model from creating overly specific rules based on just a few data points, a common cause of overfitting. It helps the model generalize better. The learning_rate controls how much each tree influences the final prediction. A smaller learning rate means each tree makes a smaller adjustment. This makes the model less sensitive to noise in individual trees and prevents it from overfitting. Think of it like taking smaller steps. You're less likely to overshoot your target. While increasing the number of trees, n_estimators generally improves model performance. Increasing it too much without controlling the learning_rate can worsen overfitting. Think of it like adding more layers to an already complex building, without adjusting its foundation. Increasing max_depth lets the trees grow much taller and more complex. This increases the model's capacity to learn intricate details, but also increases the risk of overfitting. It's like building a really tall, skinny tower, unstable and easily knocked over. This question asks us to identify the hyperparameters in scikit-learn's gradient boosting regressor that, when adjusted, help reduce overfitting. Overfitting happens when a model learns the training data too well, including the noise, and performs poorly on new, unseen data. We'll look at how changing each hyperparameter impacts the model's complexity. Increasing max_depth makes the decision trees in the model much deeper. Deeper trees are more complex and can easily overfit, because they can capture very specific details in the training data which may not generalize well. I would avoid this change if I'm trying to reduce overfitting. Increasing min_samples_split means each branch in my decision trees needs more data points before splitting. This prevents the model from making decisions based on tiny, noisy subsets of the data. It's a great way to simplify and make the model more robust. The learning_rate controls how much each tree influences the model. A smaller learning rate means each tree makes a smaller change. This leads to a smoother, less complex model, making it less likely to overfit. I think this is a good adjustment. N_estimators is the number of trees in the model. More trees usually give better results, but if the learning rate is high, increasing N_estimators too much can worsen overfitting because I'm adding more complexity to an already complex model. I see you're working with Sklearn's GradientBoostingRegressor. It's a powerful tool, but understanding its hyperparameters is key to getting good results. We'll explore how changing those settings affects how well the model works. This question is asking you to identify which changes to the GradientBoostingRegressor's settings will make it less likely to overfit the data. Overfitting happens when a model learns the training data too well, including its noise, and therefore doesn't generalize well to new data. Imagine the learning_rate is how much each tree in the model influences the final outcome. A smaller learning rate means each tree's contribution is less significant. This makes the model less sensitive to noise and helps prevent overfitting. By lowering the learning rate from 0.1 to 0.01, each tree will make smaller changes, reducing the risk of overfitting. min_samples_split determines how much data is needed to split a branch of a decision tree. By increasing this value, you're making it harder to create overly complex trees that fit the noise in the data. It forces the model to only split when a significant amount of data supports the split, which is great for generalization. Increasing the number of trees generally improves accuracy, but only if the model isn't overfitting to begin with. Increasing N_estimators without controlling the learning_rate might actually worsen overfitting, as you're adding more trees that might just be fitting to the noise in the training data. The max_depth setting controls how deep each tree can go. Deeper trees are more complex and can model intricate patterns. However, increasing max_depth drastically increases the risk of overfitting. The model is getting too complicated and focused on the specific details of the training data rather than the general trends. I'm looking at how to prevent overfitting, which happens when a model learns the training data too well, including its noise, and doesn't generalize well to new, unseen data. We need to find GradientBoostingRegressor hyperparameter adjustments that make the model more robust and less prone to fitting the noise in the training data. I'll reduce the learning rate. This controls how much each tree in the ensemble contributes to the final prediction. A smaller rate means each tree's effect is smaller, resulting in a less aggressive model, thus reducing the risk of overfitting. Think of it like taking smaller steps instead of giant leaps when learning. You're less likely to overshoot your target. I'll increase the minimum number of samples needed to split a node in a tree. This prevents the model from creating overly specific branches that might only capture quirks in the training data. By requiring more data points before splitting, I force the model to make more generalized decisions. It's like saying, don't make a decision based on just a couple of examples, you need more evidence. I'm examining overfitting in the context of GradientBoostingRegressor. Overfitting happens when a model learns the training data too well, including its noise, leading to poor performance on unseen data. We'll explore ways to make the model more generalized, thereby improving its performance on new data. I'll consider increasing the number of trees. More trees usually improve accuracy, but if the learning rate is too high, it can lead to overfitting. It's a double-edged sword. More trees can improve performance, but only if they don't overfit the training data and learn the noise. I'll examine increasing the maximum depth of the trees. Deeper trees can model more complex relationships, but increased complexity increases the risk of overfitting. This is like making a decision tree that is so complex and specific to the training data that it won't work well on new examples. I'm focusing on GradientBoostingRegressor, a powerful machine learning algorithm used for regression tasks. Think of it as building a bunch of decision trees to make predictions. We're adjusting its settings, hyperparameters, to get better results. I'm tackling the problem of overfitting. My models learned the training data too well, picking up on random noise instead of the actual patterns. It'll perform great on the data it's seen, but poorly on new, unseen data. That's overfitting. Think of it like memorizing the answers to a test instead of understanding the material. You'll ace that specific test, but you'll likely fail a similar one. You need to carefully select settings, hyperparameters, within Sklearn's gradient boosting regressor to prevent overfitting. I'll explore each adjustment and determine which ones will improve my model's ability to generalize to new data. I'll lower the learning rate. Think of this as making each tree's contribution smaller. A lower rate creates a gentler learning process, reducing the chances of the model overreacting to minor details and noise in the data. I'll increase the minimum samples needed to split a node in the decision tree. By doing this, I prevent the model from creating overly complex branches that might overfit to minor variations in the data. Think of it as requiring stronger evidence before making a decision. It helps me avoid being fooled by minor data quirks. I'll avoid increasing the maximum depth. Deeper trees are more complex and prone to overfitting. It's like allowing my model to think too much, creating very specific rules that apply only to the training data. I'm looking for all the options that successfully reduce overfitting. Overfitting can be a tricky issue. I will not choose options that increase model complexity. This problem focuses on understanding how to adjust settings, hyperparameters, within Sklearn's gradient boosting regressor to create a better model for predicting house prices. The goal is to avoid overfitting, which means the model learns the training data too well and doesn't generalize to new, unseen data. I'll be looking at how different settings influence this. This question asks you to identify gradient boosting regressor hyperparameter adjustments that make the model less likely to overfit the training data. It's a multiple-choice question where more than one answer might be correct. Remember, overfitting occurs when a model learns the training data too well, including the noise, and performs poorly on new data. I see, decreasing the learning rate makes each tree's contribution to the final prediction smaller. This means the model changes less dramatically with each tree added, resulting in a smoother, less complex model and a lower risk of overfitting. It's like taking smaller steps towards the final solution, more cautious and less prone to overshooting the mark. Increasing min_samples_split means I need more data points before splitting a tree branch. This prevents the model from creating very specific rules based on tiny parts of the training data, thus making it less sensitive to noise and less prone to overfitting. It's like saying, I only split if I have sufficient evidence to support the split. Increasing the number of trees generally improves model performance, but if the learning rate is high, it can lead to overfitting. It's like adding more details to a drawing, but if you're not careful, you might end up with a cluttered, unrealistic picture. So, increasing the number of estimators might not be the best solution here without carefully controlling the learning rate. Increasing max_depth allows the trees to become much more complex. This greatly increases the risk of overfitting because the model can fit the noise in the training data more precisely. Think of it like drawing a really detailed picture. You'll capture lots of detail, but you might lose the overall essence of the image. These are the possible solutions to the problem presented. You must select all the correct options to completely answer the question. This instruction indicates that the quiz has more than one correct answer. You need to find and select all the hyperparameter adjustments that reduce overfitting in the gradient boosting model.